Hi, I'm going to be talking about how computation can be constructively enacted and its relationship to cognition and consciousness. So we'll start with apartness relations. Apartness relations are a constructive version of equivalence relations. Instead of showing when things are identical, we show a difference. This puts equality and symmetry as the fundamental notion in constructive mathematics. If we were in the classical world, then it would be equivalent to classical equivalence. As an example, the inequality relation on the real numbers is semi-decidable. If two numbers are different, then we'll always come across the difference eventually. So we can always halt with no eventually. But we can never halt with yes, because we will always have an infinite amount of digits left to check, assuming a naive checking algorithm. So here's just some notation for apartness I'll be using. The key points to remember is that apartness witnesses distinguishability with regards to some aspect. Okay, so if there is symmetry, then you cannot distinguish between the symmetric items internally. Sure, you can specify the point at x equals 0, y equals 1, for example, in a unit circle, but that's only possible thanks to the external coordinate system. If something is to be distinguished, then there must be some difference between the thing and all other things. That is to say, it is not completely interchangeable with others of its kind. In other words, it is not invariant under some symmetry, and therefore symmetry is broken. By providing a witness of an apartness relation, we are showing that its associated symmetry is broken. We are showing that two things are distinguishable, and therefore they must be something fundamentally different. Incidentally, this is the first task of the scientist. In studying a new phenomena, the first thing to be done is to look for ways to distinguish between classes of instances of that phenomena. Okay, so in order for something to be, it must be distinguished from those that are non-being. That is, there must be something which makes it be, because if it didn't have it, then it wouldn't be, right? Now, in order to distinguish things, we must see that they are apart. Otherwise, they would be indistinguishable. Being is distinguishable from non-being, and therefore they are apart. Therefore, there is a broken symmetry, allowing the thing to be. We thus will define being as a property of a thing that is apart from its non-being. So first, let's denote the non-being of a thing by a solid circle modality. Then for some type A, we define its being by its apartness from its own non-being. Now, Hegel actually starts his science of logic with being and nothing. These are both aspects of the same thing, becoming. So we've shown that symmetry breaking is required for a thing to be, because being is distinguishable from not being. Apartness witnesses distinguishability by showing a broken symmetry, and symmetry breaking is required to distinguish things. The approach we have taken to this point also shines light on a path to show the opposite, that being is fundamentally about construction. After all, to be, you must be constructed by breaking some symmetry somehow. Now, to be a constructivist is to demand witnessing the being of a thing, as opposed to merely witnessing absurdity of its non-being. To witness being, we must witness distinguishability from not being, such as via an apartness relation. This is different from witnessing absurdity of not being, as you receive a certificate of apartness in finite time, whereas absurdity of not being, that is, absurdity of absurdity of indistinguishability from being doesn't actually give a certificate of apartness, as it doesn't construct the broken symmetry. By the way, feel free to ask questions just whenever, because I am going way too fast. So this actually suggests a kind of constructive materialist foundation for the Platonic realm. Materialism holds that abstract entities are subordinate to material processes, and as such, materialist philosophers have generally dismissed foundations of mathematics that consider mathematical structures to be in some sense existing in a Platonic realm. By considering becoming as construction, we see a way to recover the existence of this realm while still being firmly materialist. The realm is comprised entirely of the broken symmetries. So obviously this has been all incredibly abstract. So let's ground it with two examples. If anyone has played the computer game, the original Doom, you may recognize this as the very first level in Doom. So I just skipped ahead, sorry. Firstly, consider an empty, non-compact space without a coordinate system, say torses over R3. Let us choose to introduce parity by breaking translational and rotational symmetries, by splitting the space in two via a plane. We introduce more planes to cut away a cube. We are inside the cube if we cannot see to infinity without crossing a plane. Otherwise, we are outside. So in this way, we have constructed something purely by breaking symmetries. What we have made is indeed defined by how we broke them. This technique, called binary space partitioning, is often used as a geometry representation in, for example, computer graphics, for example, Doom. That was still fairly abstract, so let's take it even more down to earth. Consider a solid sphere of steel. We may use a milling machine to remove material, that is, to break symmetries, and produce, say, a spinning top. And I can't quite remember what sculptor said it, and I'm not going to look it up right now, but to quote them, "I know when I'm finished, not when there's nothing left to add, but there's nothing left to take away." That's just kind of an aside that seems relevant. Okay, so computation is the realization and embodiment of construction. To construct a proof of a proposition is to compute a term or evaluate a morphism in a category. Each individual step of a computation is a computation itself, even in continuous computations such as kinematics. This may involve like hypertasks, for example. In general, computation is transformation of input into output. If no transformation has taken place, then there would be, capital B, no input or output. Indeed, if we are unable to determine transformation has taken place, then we would be unable to distinguish between input and output. In general, we can distinguish between input and output, even in hypergraphed or compact closed categories where there's no sort of inherent directionality of input and output. We can distinguish between the morphism inputs and outputs. There is, therefore, a broken symmetry. So, following this line, computation can be identified with the process of breaking symmetry. A lambda abstraction, for example, is a specification of how the symmetry is broken. This also suggests that there is a way to construct a modal type system for specification of symmetry breaking, perhaps keyed type theory, for example. So I went way too fast, and this is almost the end of the talk. And we're finally ready to talk about cognition. So cognition is Paraphrasing, cognition thinks, therefore it is. If cognition and consciousness is computation, and I'm just assuming it is here, I'm just assuming it is therefore a constant process of breaking symmetries. Note that this is distinct from using symmetry breaking as a problem-solving strategy. For example, in satisfiability, Boolean satisfiability solvers, a common strategy is to look for ways to reduce the available space of solutions by looking for ways to eliminate redundant options. That's what I mean by using symmetry breaking as a problem-solving strategy. So one possible manifestation of this is particles of thought, which kind of follows on from what Kobe alluded to right at the end. They are pseudoparticles or topological defects in conceptual spaces with non-trivial homotopy groups, which may be 0-dimensional, 1-dimensional, 2-dimensional, whatever. Yep, that's it. Anyone got any questions?